Hola, hi, and hello. Welcome to the Tech Geek Podcast. I am your host, Sukriti Aduvanshi. Hope you guys are staying safe. So, folks, today we're going to talk about serverless architecture, a technology that almost every organization had to adopt after the pandemic kicked in. Serverless architecture is a method to build and run applications and services without having to manage infrastructure. You no longer have to provision, scale, and maintain servers to run your applications, databases, and storage systems. Agility, scalability, and security are a few clear advantages in the adoption of serverless architecture. So, where we understand and know the clear accelerated adoption of this model, we should also broaden our horizons, learning what opportunities it brings for you as developers. And to elaborate on this, today I'm in conversation with Shantanu Preetham, the Chief Technology Officer from PayU India. A seasoned technologist and engineering leader, Shantanu has more than 2 decades of experience in building software products and driving digital transformation strategy. An expert in creating customer first technology solutions, Shantanu has led and mentored global teams to build highly scalable cloud platforms such as omnichannel and e commerce platforms and transportation ecosystems, including CRM systems for Fortune 100 companies. Welcome to the show, Shantanu. I'm delighted to have you here with us today.
Thank you. Thank you very much, Sukriti, for the great introduction. And yes, you are so right, Sukriti. First of all, I greet every listener and everyone on the call. Very good afternoon. And most important, assuming everyone is keeping in best of their health, and wish them a very happy and, pinkiest of their health. To begin with, Sukriti, yes, my role in PayU is I'm accountable for complete technology innovations and building the fintech platform at a scale at PayU. And yes, you are so right. With last 1.5 years, unprecedented times of this pandemic, there has been some interesting technology advancement in the world, and especially the serverless computing or serverless architecture, what you have mentioned and what we have been hearing, it's for sure has taken a giant leap in adoption life cycles of different organizations. Back to you, Sukriti.
Thanks, Shantanu. I'm looking forward to some interesting insights from you during this conversation. So let's get started with the questions. So to start with, Shantanu, help me understand what are the initial building blocks of serverless computing?
So before directly going into the building blocks, Sukriti, I know you gave a right two-liner definition of serverless computing, but I thought I'll just take a few minutes to help all our users. If someone who has dialed in for the first time and hearing this phrase serverless computing for the first time, I will like to define what it really means. It's a very simple, it is a way of cloud computing execution strategy. It's a very unique and innovative way where it allows us to build and run applications without really needing to manage infrastructure. Now people will say that that's what cloud was about. So what is the big deal about serverless computing? Then what is different from cloud? So cloud is the overall whole container in the realm of this whole thing runs. Now serverless architecture or serverless computing goes one level up. So basically what it allows is, it allows us to decouple the key operational accountabilities from our architecture. Like what could be those operational accountabilities, like provisioning, scaling, maintenance, resources on demand, all such kind of operational accountabilities, common infrastructure management tasks, scheduling, patching, provisioning, that all is left to the cloud providers. And in turn, then what it does is it gives a lot of bandwidth to engineers to actually dedicate their time on involving the business logic part of their application or process. So in nutshell, Sukriti, serverless computing runs the code on demand in a stateless behavior, in a stateless model, in a stateless container on a per request basis, and it scales beautifully with the number of requests which are served on it. And the best part, which many people would love to hear, is literally you need to pay for only what you use. This is, the cloud was also like that, but there in the cloud, the whole box you get to pay and use for. But here it is actually literally you pay only for the invocations your services are making and functions are being invoked. For their uses you need to pay for. So in turn, it enables the users to pay only for what you use and never to pay for what you don't use or where the capacity is idle. Now, to come to then how such a, what constitutes then serverless computing, or what are the key defining blocks of serverless architecture? So in nutshell, Sukriti, a serverless computing is primarily sitting on a backbone of event-driven architecture or event-driven thought process. And from that perspective, there are only three key constituents of serverless architecture, which is the events or the sources of events themselves, which become the invocator of the serverless architecture paradigm. Then the key defining block of serverless computing, which is called a function as a service, which is the functions themselves which do the heavy lifting. And last but not the least, these functions which rely on the different kind of shared resources what you can think of. So now if you visualize, Sukriti, it is a three-layered thing. So what are the things which drive the invocation of serverless computing? Events, or the source of events itself. And what are those? For example, you make a API request, you make something called that, pay 1,000 rupees to Sukriti. So there is a payment API from a bank which Sukriti has an account for, where it says that pay 1,000 rupees. So that request, the event that now I have to pay 1,000 rupees for that API to Sukriti is an event itself. So the request of an API is a starting of that invocation. Now there is a place where the actual code is written, that how to do the credit and debit of the money. That is a function, that is the key constituent block, and that function resides and decides on a shared resource, which could be anywhere, which is called the resource. So event, the function, and the resource. So these are the key fundamental blocks of a serverless architecture paradigm. Sukriti, back to you.
Those were some, good basics that you shared, Shantanu. Thank you so much for that. Moving on to the next one. What are the main advantages of adopting a serverless architecture? I know this is a very basic question that people should know, but to have the right reasoning behind it, I think that's more important to have an understanding of.
So first, again, I will start from Sukriti. Everyone loves money. Everyone, when you are a CIO, when you are a CEO, or when you are a CTO, or even when you are a VP of engineering, or when you have any time you have a P&L accountability, Sukriti, what is the one thing always bothers you in today's world? Because your business is growing at a amazing exponential rapid scale, right? In last especially 18 months, we have seen, Sukriti, the digital economy, the growth of digital economy with the vision of, our government of Digital India. We have seen the way our digital economy has grown. It is absolutely exponential. Then can we afford to have our operational cost also at the same level? Absolutely not. And this is where the serverless computing paradigm comes to all our benefit. What it does is absolutely reduced operational cost. In nutshell, as I said earlier in my introduction also, no need to run a server 24/7. No need to pay when a server is idle. No need to pay when your compute is not being used. So similarly to IaaS and PaaS, the whole engineering and infrastructure cost reduction is one of the most basic and fundamental advantage of serverless architecture. You pay for managed servers, you pay for databases, you pay for application logic in terms of an overall cloud thing. But when you move to serverless architecture paradigm, you pay only for the invocation of the function it calls for. else you don't pay. So basically, if you see, which earlier also I mentioned, Sukriti, ordinarily servers use only 10 to 15% of their computing power, but we need to pay for the whole compute uses. But when we are using serverless computing, there is no need to have a server running 24/7, and it allows the serverless providers to charge only for the time that function was running. So that's one of the key advantages. The second is very seamless operational management. As a as a CTO or CIO of the organization, I don't need to figure out that what are the infrastructure pitfalls of my whole path, because that's where the serverless computing will take care, because there is a very clear separation, or you can say decoupling, between infrastructure services and the functions which run as a service as a key constituent block of this paradigm. Then the second part is, because these functions have automatic scaling capability, not only it reduces the cost, it reduces the overall management overhead. That's another advantage. The third advantage, very, very important advantage, is, as I earlier called it out, that your engineers, right, who are and in today they are becoming the most important part of our whole human capital life cycle. We allow the engineers to focus on the core business logic capabilities. We allow the engineers to focus on what is more important to build rather than what is needed to manage. Let them, the serverless computing, do that lifting. So basically, if I need to summarize, Sukriti, reduced engineering lead time, I can see as a CTO or as a manager of the people who needs to run large organizations, enhanced developer productivity, no need to reserve a fixed amount of hardware or bandwidth, innovation and POCs become faster and easier, reduced operational costs, and of course, last but not the least, automatic scaling and very minimal maintenance cost. Sukriti.
Great. So, we've moved on to two levels of our conversation, Shantanu. The third one that I need to know is that, when organizations are trying to adopting serverless, right? So, what are the key decision criteria one should keep in mind while adopting serverless architecture? Any tips and tricks that you suggest?
So, yes, this is also a very important decision factor, Sukriti, because when you hear this podcast, you will realize that, oh, the advantages are manifold. Then why everyone is not moving to it? Well, as you know, everything comes with its pros and cons, and everything comes with an architectural decision points. So some of the things, because it allows or enables the transactions to be isolated and scaled easily, it becomes a very good scenario and use case for high volume and parallel workloads. Now I'll go to a very interesting scenario, Sukriti. I'm not sure if you have ever heard of, Sukriti, something called Monte Carlo simulations, Sukriti?
Not really, Shantanu. Would love to know about it.
Do you invest in a stock, Sukriti? Or of course, some of your, relatives may be spending investing in stocks, right? So now very simple things is, won't it be so easy for us to know that if I can predict the outcome of a stock, what would be the price of the stock, right? Or something like that, right? So what is in reality a Monte Carlo simulation, Sukriti? It is used for portfolio management and financial planning in financial segments. They are primarily used to model the probability of unpredictable outcomes, the outcomes which can't be easily predicted. And it is it is a mathematical method, algorithmic method, which allows us to estimate the future outcome of something which is really hard to predict event, Sukriti. So now some of using IBM functionless as a server programming paradigm, this Monte Carlo simulations was used, and you would be surprised to know, Sukriti, what earlier used to take around 250 minutes with 100% CPU utilization, same thing was able to be done in only 90 seconds with 1,000 concurrent invocations. So that powerful, a serverless programming can be if used in the right business use case and in the right way it is used. So basically what it means is wherever there is a heavy load, background task, decoupled tasks, or multimedia use cases, we can very happily use serverless programming paradigm. If suppose we want to create online ML-based chatbots, IoT devices, Sukriti. So now it is everything, right? We have switches which are smart switches. We have refrigerators which are smart. We have, our whole home is connected, Sukriti. Correct? Refrigerators are connected to micro oven is connected to switches which are Wi-Fi enabled, then TV, Alexa. You can run everything from using your Alexa, right? So everything are IoT devices. Now these IoT devices, Sukriti, they generate millions of events in a second. And now to process these events, the serverless computing becomes an absolute best architecture model to process those events in and take a decision and process them in real time. That's where they can act as a wonderful backend for IoT devices. Many times we have third-party services which are black boxes. It allows us to even host and manage them. And as I talked about Monte Carlo simulations, it really acts as an enabler for boosting computing performance for standalone, stateless asks, Sukriti.
That's very interesting, Shantanu. That some good insights from your concept of Monte Carlo, I should say. The next one is a little more detailed that I would want to, want you to share with us. How serverless is similar or dissimilar to microservices from technology perspective, and what are the strengths of both while implementing the application, and how serverless can improve resiliency? Last but not the least, how can it help in creating a better customer experience, which is of utmost importance to any organization?
Sure. So this is again very interesting question, and people actually use many times interchangeably that okay, we have been using microservices were supposed to be another innovation in whole REST paradigm, whole new way of architecture methodology. Now what is this fast, what is this serverless computing? And I know this can become confusing. This can become, intimidating also at times. So what I will say is, in a very simple perspective, Sukriti, which will help all of us to understand, microservices is a way to, architect an overall application, whereas serverless is a way to run an application. It's a very simple, way to understand it. So microservices, they're the whole, as I talked about that API to make a payment, right, Sukriti? So that API where there is an API, that there is a logic of API, there is a database which serves the API, and there are dependent APIs which call each other, is a whole paradigm and whole set of microservices which enables a banking transaction. But whereas what we can do is we can take out some parts and components of that microservice implementation and we can run it as a serverless. So what it means is microservice overall architecture can constitute within itself multiple function, as a function as a service components, multiple serverless components within itself. So it is like a microservice architecture can compose multiple fast components or serverless components side. So they actually, I will say, they complement each other. They aid to each other's architectural beauty instead of acting as a competitor to each other. That's where I will say that how it is similar or dissimilar. It is similar from a perspective that it is a architectural paradigm. It is similar in a perspective that it believes in decoupling of the whole, the way microservice is a decoupling of layers, the way microservice allows the components to be very atomic and granular in nature. The same way serverless programming believes in the same architectural first principles. But at the same time, microservices many times are very heavily dependent on states, because at times you need a state management for some of the things where you need some future or previous interpretations to happen in your architecture. Whereas a serverless implementation, it is not the best way, or I will say that best mechanism to think about a state implementation. So from that perspective, it can be different. So again, I will say that depending upon use case to use case, we need to take a call that where we go for a pure serverless architecture paradigm or full-fledged microservice based architecture. For example, a serverless application may not be suitable for where we are maintaining the states or socket-based communication, because at times there are many places where socket-based communications need to be used, whereas a serverless paradigm doesn't allow us to use a socket-based communication because it has its own life cycle and a context. So that's where I will say the difference between microservices and serverless architecture paradigm. And again, as I said, that they complement each other rather than being competitive in nature. But most important, Sukriti, I will again put a very, very fundamental stress upon it. And that's how I started my today's conversation, is we need to understand what is a serverless architecture, how function as a service belongs to serverless architecture paradigm, how the different constituents and building blocks of a serverless architecture are. When we understand the fundamentals of serverless programming paradigm, then we will be able to use and apply in the right use cases, and then we will be able to make the most out of it. Now, very simple thing. You asked me how easy, or I'm assuming your question was how easy or complex designing the serverless architecture was, right, Sukriti? That was another question you asked me. Sorry, I think your question was too long. So
yeah, so
was that also a part
the last part was about how it can help in creating a better customer experience, Shantanu.
Okay. I'll come to that. So I'll just want to take a few minutes to even, some guidelines for design and maintaining the serverless architecture. So very simple. There are three commandments. Let ensure that each function is performing only one action. Don't have, redundant actions performed by your functions. Don't try to make embedded function calls. Don't make too many chatty functions calls. So ensure that functions don't call other functions, and try to use as minimum libraries in your functions as possible. So this is 3 development commandments I will give Sukriti to engineers when they are trying to maintain or develop a serverless architecture. Now, coming to from a customer perspective, Sukriti, I will be very candid with you. To the end customer, it really doesn't impact them as much. But as a provider of a service, as a provider of software solution to that customer, we can make a immense beneficiary impact to the customer by adopting to the serverless architecture. So what it means is, Sukriti, if the cost is less for me as a provider, I can in turn pass the same cost benefit to my end customer. if my development productivity is increasing, so it means that in the same time frame I can develop much more innovative and higher innovative products at a scale for my customers. So if my maintenance cost is reducing and my maintenance life cycle is reducing, that it means that I could be in the same maintenance cost, I can provide a much higher quality of service to my customer. So what customer gets, Sukriti, in all this is implied benefit of every benefit which we as a software provider and implementer get. Sukriti,
Yes. No, so
any part of the question I left?
you did not. In fact, you answered the last question that I had about designing and maintaining serverless architecture. So thank you so much for that. And those were some fantastic insights, Shantanu. Thank you for being a part of the show and sharing some great inputs around the building blocks, advantages of adopting serverless infrastructure, enhancing customer experience, and designing and maintaining serverless architecture, Shantanu.
Thank you, Sukriti. And I hope our listeners and viewers are able to, take some advantage out of our today's session. And my only earnest request would be to them is, after hearing this session, go and read, and most important, try it. For sure, try it once, because unless we don't try, we will not be able to harness the benefit for ourselves.
Absolutely right, Shantanu. So thank you to our wonderful listeners. Hope you enjoyed the conversation have and earmarked those useful tips and insights Shantanu mentioned. I will be back with another episode super soon. Stay tuned to TechGig for all the tech updates.